Okay, we should be live, right? Or no?
Sure.
Who knows?
Yeah.
Yeah, we're live. So, hello everyone. Andrea is flying to conferences today, so won't be able to join. And we have a guest. So we have guest Dmitry, very experienced Postgres expert, and before that Oracle expert, or Oracle DBA, right? And so, hi Dmitry, hi Kirk. I'm going to start this discussion and go to distribute links so people could join us. But the the topic today should be ASH, my favorite, active session history, wait event analysis. And this year, I feel that we have so many ideas around this, right? So I'm building my small, like very simple tool for small clusters called PGAsh, purely SQL and PL/PGSQL implementation of like moderate frequency sampling of persistent activity with wait event and query ID every second, right? Without any extensions, so it can be used everywhere. We also have a Google Summer of Code where Kirk is super involved, like answering, I think, every email from candidates. And we have wait event gaps project, right, to close gaps discovered by Cloud Code uh, after my request. So there
Yeah.
are some gaps too, yeah. Because sometimes we see null, and Dmitry knows this very well. We talked about it so many times. We see null, and some tools visualize it as a CPU. And sometimes it's not CPU at all. It's some wait event, which just not instrumented. So I think Postgres 20 already. Postgres 20 should have better shape. And Dmitry just like suddenly a few weeks ago started posting on LinkedIn a very interesting tool. So I will let you, Dmitry, to tell your story about this new tool and why it's needed and what's the use case and so on.
And introduce
Yeah,
yourself as well, Dmitry. Go ahead.
yeah, I'm Postgres expert, and I mean I can call myself Oracle performance expert because I have a certificate from Oracle officially.
How old is this certificate?
I don't know. The last one that I got is I mean the Oracle RAC performance thing. I think something 2019, 2018, something like that.
It's not that bad. My Oracle
No,
experience stopped 23 or 4 years ago, so it's very different. Yeah, quite fresh.
yeah, yeah, and I mean it's why I'm mentioning it because I mean I don't know 10 years ago something like that when I start migrating from Oracle to Postgres. In Oracle you have fantastic observability tools and there are and tons of books, articles, guidelines from Oracle itself, how to observe, how to measure performance, how to tune, how to analyze, and everything. And when I switched to Postgres, I was kind of surprised how I mean, the way of performance analyze is done in Postgres was very different in comparison to Oracle. And you know that we discussed, I don't know, 7 years ago, so something like that with Unique, when I showed you how the active session history thing works in Oracle, and I showed you Postgres active session viewers, PASH, project that kind of pretend to be active session history thing for Postgres. And how to say, all my time in Postgres, I was thinking how to implement something like that in Postgres. In Postgres, I think one of the most mature projects, it's PG-weight sampling extension from Postgres Pro. It's really good one. I mean, and it gives almost everything that you need to build really good observability for wait events in Postgres, but still has some limitations. And recently, I work extensively with the Postgres performance problems when you need to understand what's going on very, very on a low level. One of the last cases that I worked was the query when the execution time jumps from few milliseconds to 1 second when it was killed by the timeout. So, I mean, from 1 millisecond to 1 second, it's really big difference. And it happens not every time.
If you sample persistent activity every like 15 seconds, it's really hard to catch this, like, and understand what's happening. Even if every 1 second, it's not enough. Precision is not enough, right?
Yeah, and you really hard to distinct which one. I mean, sample belongs to which session. And I spent few days with the eBPF tools, strace, and so on, trying to understand what's going on. Because I mean, of course, one of the obvious ideas was the plan flip, right? Everybody would think about something like that. But the query itself was so simple. It was the primary key lookup. So I mean, nothing can happen with it. So that's why I thought
except lightweight lock manager can happen with it, right?
Yes, but I mean, it's not the plan flip. I mean, you really hard to, I mean...
No, I mean lock manager contention, if it's a lot of QPS might happen.
I mean, the regular lock can happen or something. I mean, the heavy lock, I mean, lightweight lock, but with I was trying to find what happened, and it means I will need the tool that would be able to trace what's going on with the very short queries and with a random query, I mean, the backend. So any backend can run this specific query. And I, again, I start thinking how I would solve this problem in Oracle. And it was, in Oracle, there is a 146 event that gives you really tracing solution for backend, for any connection. You would see the plan, the parameters, everything. And what would you see? The wait events with the histograms. I mean, how long it take? I mean, the average, the maximum, the quickest wait event, the distribution of this wait events, the files it's touched, the I/O calls, CPU calls, everything. And I start building this solution for Postgres. I built the proof of concept. It worked. It was mixed solution. I also posted on LinkedIn, so it's open project on GitHub. It's a mixed solution with the extension that gets the SQL query and the plan and parameters, everything. So I will get to the thing really short.
Okay. You know what?
Because this story is, I mean, it's the bridge would be really short. And when I posted it, so I got the comment from Jeremy Schneider that it's not 146. It's not tracing.
Let me explain. Jeremy Schneider worked at the RDS team for like many years and now at Geico. And he's a big fan of wait event analysis, active session history, ASH, or like what was called performance insights or now database insights in RDS. And I think he was at RDS team when they implemented it. And this influenced many people in Postgres community. But that topic was brought from Oracle, basically, right?
Yes. Even the color scheme is from Oracle. So I mean, if you comes from Oracle, you see the familiar colors, and finally I'm at home.
Like green is CPU, blue is I/O. Yeah. So what did he say? Like it's not tracing or it is tracing?
Yes, I mean, you cannot call it 146. It's not tracing. It's sampling for wait events, and it was, I mean, very true. And I said, but I mean, it's a limitation of the Postgres. I mean, there is no way to do it. I mean, and it's true.
To do what? To do more frequent sampling?
No, to have the real tracing, not the. I mean, of course, you can increase the frequency, but it's how to say, given a limitation, it's sampling.
So 1 second, like just to like unwrap this. When we do query analysis, we have two major tools: PGStat statements and wait event sampling from PGStat activity. Sampling is like good or I don't know. Like it has benefits. It's good, but it has the problem that it's just like you have some frequency. So what happens between those 2 points? Who knows, right? PGStat statements is good because it cumulative metrics for query ID. We track all successful queries. Right, and idea is what if it would be possible to capture all wait events for some session, right? Or multiple sessions, right? This is the idea, like trace all wait events and understand conversions between them for specific execution of specific query, for example, or session, right? This is the idea of tracing, right? Not sampling, but real, like cover it all.
Yes.
Yeah, tracing is the low level debugging in Oracle, where you can say, hey, for this session, turn on tracing. It creates a .trc like trace file, and that is actually almost like attaching a debugger to the actual process. It produces that kind of output. So the upside is it's incredibly exact. The downside is it's for this one session. And if you don't catch it, what you're
An
looking for in
observer
that
effect.
session, the
The
observer,
observer
right?
effect. Is,
Yeah, well, yes, and if you turn this on wildly on a machine, you can crush it. So
I mean, it's this as the tunnel podder said recently in one of the comments, the observability is investment. Yes, it's not for free, but I mean, I would pay, I don't know, 15%, 20% of the performance, but if it gives me the way to understand what's going on when it stopped working. Because I mean, Postgres is, I mean, fast, yeah, fantastically, but sometimes it's just blips and stopped working, and you have no idea what's going on because PG-weight sampling does not register, PG statement does not register the canceled queries.
yeah.
I mean, everybody
Yeah.
knows the limitations, so I would not go there.
Everywhere
So
limitations, yeah.
yeah,
And like I'm okay to pay price if it's reasonable, like 10%, for example, of observer effect. If it's not like 1,000%.
and
Yeah.
yeah, and basically in Oracle, you do pay it, you just don't know it. Because I mean, so you get the Oracle, compile the binary, so you don't know how much, I mean, of the performance is paid for
Yeah.
observability.
Who knows?
I mean,
Yeah.
there are some, I mean, crazy numbers over internet that's, I mean, the Oracle spends about 10% of doing the work, and the rest is self-managing, self-healing, building the other observability and other stuff. So, I mean,
10% muscles, 90% fat, right? Something like
yeah,
this.
yeah.
Okay.
And okay, so back to the topic that I got this comment that's I mean, it's not 146 because it's not tracing. I said yes, it's, I mean, very true, because but it's given the limitation of the Postgres. Because I tried to find a real tracing solution for wait events, and the problem is that in Postgres the functions that used to set and unset wait events are inlined and they optimized out when you compile. So nothing can catch the moment when you call these functions. So I mean, it's so how it's Postgres code now done and how it's compiled. Yeah, and I was brainstorming again and again with the Claude and Gemini. I'm trying to find what maximum I can squeeze from this sampling approach. I'm just getting the old books from Oracle and from my university about the queuing theory. So I'm trying to find the way of how I can apply this math to it. And once I just write the message to the one, I think it was Claude, that stop, I mean, what a pity that we cannot trace Postgres wait events. And he said, no, you can. And I said, what? And show me. And Claude actually showed me the way how to do it. I mean, no way that nobody else noticed before me. So, I mean, I'm not really C hacker or something. So, I mean, and so why it's not done? I didn't believe it. So for a few days, we built a proof of concept, and I tried to, I mean, break it, find the corner cases and so on, because I just cannot believe that, I mean, there is a way to trace wait events. And so I can show what
so
we
show
actually
us.
built. Yeah.
Yeah. So this like it's so interesting story, right? Like sometimes it's worth complaining and like just to AI and then see what it says and if yeah.
Oh my
Okay.
gosh.
Yeah. So it's just, let me.
What's the language? Is it yeah?
Okay.
So what
Sorry.
did you use technologically? What's the technological stack here?
Sorry, I mean, it's again, so it's demo problem. So when I start showing something, it just breaks. Yeah.
There we go.
Okay, so the server is so it's C. I mean, the core is written on C, and eBPF used to catch the events and to get it from the kernel space to the user space to offload. The client is just Go library. Single Go binary. So what we're looking at is, it's still a proof of concept stage, but I think it demos the idea that we can go with the precision that we like. It can be nanosecond precision. The
Nanosecond.
colors, yes, because it's tracing. So the precision is limited only by the timer from the Linux. So it goes with a nanosecond precision.
And does it affect the level of observer effect if I?
Yes,
Yeah.
it works now enabled for all backends, including the background workers. So what I measured maximum in quite pathological scenario, it was 13%. Why I'm saying pathological? Because the observer effect depends on the number of switches between wait events. If you run, I don't know, for a few milliseconds one IO call, so it would be just reduced one wait event. But if you have lightweight lock and you have CPU, it can be switched back, I don't know, few K per second. So the observer effect would be higher. And in this case, when you read a lot of blocks from OS cache, so it's quite fast. So in this case, you have the 13%. In kind of an average, some PG bench test, so it was about 5%. So, but I'm not saying this is the the exact numbers, but it gives the idea of the observer effect. So I hope it will be something around 10% because it's in my plan to look closer on performance, how we can I don't know, squeeze maximum for it. Okay, so what we see, so it's what called in Oracle the time model. So it's for this period. So what on the next step? It's
One second, Dmitry. Like, let's just explain. I know, like, not everyone, like, many saw performance insights and RDS and other Ash like wait event analysis. Like, let's maybe discuss a little bit, just a few seconds on the graph, like how it's organized and why, for example, this dashed line for CPUs.
Okay. Yeah. So the horizontal axis is the timeline. The vertical is the number of active sessions by this period of the time. So here we see, for example, that CPU is the green, so it means that the yeah.
You use CPU star. You stopped doing this. It's a pity. It's
No,
here, but not on the
sorry.
graph. Not on the graph. Yeah.
Yeah.
Star because we like
It's
doubt
fake.
without maybe CPU or maybe some uninstrumented wait event, right? So we talked about this many times.
Yeah, and even if we go deeper, that on CPU, it's not that easy to distinguish if it's waiting for CPU or actually executed on CPU. So, it's even more complex, but you're right, way more important that in Postgres, what we treat as the CPU, it's basically null wait event, and it can be just not covered by any wait event, as you already said. So it can be even writing to the log. So, it can be quite...
I'm sure it will be better in a couple of years. We're working on this.
So comments on this screen just for the novice people, and that's kind of my role here to be the novice, but this looks a lot like Enterprise Manager. And for the people not necessarily used to looking at that, what it allows you to do and what it's set up for is, first and foremost, you get a snapshot over time. This could be 24 hours, and you get to see if there were any performance blips, like all of a sudden you see that intensity in the center of the screen. The things you could do from there is you could actually select and zoom in. And as you select different time frames and zoom in, it changes and reduces on the bottom what
Yeah.
queries were
So they
actually
are
active in
correlated.
that time frame.
Correlated.
So
Yeah.
there's a correlation.
Yeah.
And so for somebody who's trying to navigate this just at a high level is you're looking at a summary congestion of active sessions and what resources or wait statements, what they were trying to do and being blocked doing is a way to think of it. Not only that, as you click on those things and as you zoom in, now you can get down to the exact queries that were running. And from there, you can start looking at the weight profiles. Some of them look healthy, right? Whatever, some of them look bad. And now this is where you're trying to dig in. The beautiful part about Ash in general was its history. And so you can come in Monday morning and find out there was a complaint about something on Sunday at 2 p.m. And you can
Yeah.
scroll back to Sunday at 2 p.m. and zoom in on it and actually drill in and see the same stuff repetitively and from two or three different angles to find what you're looking for. Okay, cool. I apologize,
No,
Dmitry.
No,
that's
no.
great explanation. Yeah.
Yes.
I'm also super glad that for both of you, Oracle experience is not as extremely rusty as for me. So Kirk also definitely worked with Oracle recently, so it's great to compare tooling here. Yeah.
Yeah, so this is great.
But
And you get
yeah,
spoiled by this. When you
yeah,
have it in Oracle, then you come to Postgres and you're
yeah.
looking for this.
Yeah. By the way, all query IDs are positive. I doubt, like maybe there is some bug there because
Yeah. I
some of them
also
should be
noticed.
negative.
100%, I think, yes. I mean, it's also listed in the bugs. That's, I mean, it can
Mhm.
be true, yes.
So Kirk mentioned you can zoom. Can we zoom in and
Yeah, I
see
hope
that
it will work.
resolution is? Yeah.
Yes. Oh,
Oh,
fortunately enough, it works. Yes.
So can you
So,
zoom even more? Like, what is the actual resolution we can deal with here?
so yeah.
Is
Now
it
we
milli?
go. So on
It's
the screen it's millisecond, but I mean you can go to the nanosecond.
so now we
We've
cannot go closer to milliseconds because you export it every 1 millisecond, or we can go
no.
further.
I mean, so it seems zoom in does not work
Th-
for
th-
you.
This this is already not possible in any Ash tools.
Oh,
oh,
I
he's
know.
no. So
already,
yes,
look at
it's
his zoom level. Oh my God,
Yeah.
it's 1656.31. So 31 seconds at the beginning and 31 seconds at the end. So he's
Yeah.
down to millisecond zooming. 212620 to 214524.
Well, looks
Nice.
like lines change like maybe every millisecond in this case, but you mentioned it's microseconds,
yeah,
and
yeah.
so.
So it's six digits, so it's microsecond. Yes.
Yeah, yeah.
That's I never saw this. So already, like I saw many Ash tools, maybe five for Postgres. This is first time. Like this is amazing. And I'm definitely going to start using it for benchmarks when I can pay observer effect price to study all the details, to reproduce some problem and study, like to zoom into like under
Yeah.
millisecond. Right, that's amazing.
Yeah, and one of the, I mean, how to say, good things. So it was not intentional, but I mean, it happened. So it generates files that you can replay. So
Mm,
you can just record your performance during the benchmark, for example. I mean, and just save it somewhere, and I don't know, see
like
what's going, what
trace files.
yeah, what
Yeah.
happened? So what's we waited,
Wow.
even the queries we executed in which order, so which one of the
And all started from you like complaining to Cloud Code that it's pity that it's not possible, right? It
yeah,
said it said like let's do it, right?
yeah.
So let's yeah, I cannot stop being amused by this. Oh, what's this?
Yes, it's one of the most interesting thing that that cannot be get with the regular sampling. It's a histogram, so it gives you the uh, on the heat map, you can see the
Mm,
distribution of the weight events. Here, for example, what the case that actually triggered this entire thing that I mentioned with the query that jumped from 1 millisecond to 1 second, it was the problem with the I/O, and the I/O call from 1 millisecond jumped to 300 milliseconds or something like that. I mean, it's almost impossible to catch it with any existing tools. But with this tool, you would be able to see that for this query, for example, on the heat map for the problem period, for example, latency for IO call for some reason jumped from I don't know 1 millisecond to 300 millisecond, and now you know where to look at. So now you need to look closer to your storage thing, not to something else. So really, it's one of the, I think, obvious benefits for tracing.
Yeah, can you zoom out, or maybe we should use filters, class and event.
Yeah. So
yeah, because it's becoming more interesting, I guess.
Yeah, let's, I don't know, well, so yeah, we see that valsync, I mean, hot some nanoseconds, yeah, but still, I mean, during this period, so it's a timeline, it's a heat map.
But those are those are below 1 millisecond.
Yeah, because I mean,
well, they can be technically below 1 millisecond even with 1 millisecond sampling, because if you have multiple active sessions, but they spend time in this wait event only like infrequently, then like it can be divided by the number of sessions and you have like 25%. But I guess here it's different. It's really microseconds precision.
Yeah, but you see that, I mean, there are some outliers. I mean, the hottest place is here, but still some outliers. So
occasional.
I mean, this type of things really can help you to find the problem. I mean, if you investigate some on a really low, very low precise level, so you will see these outliers. Oh, finally, the problem is
this like feels like some super professional tool to investigate some stuff, which you usually can do only with like GDB or something, and then like dealing with long traces and like files, like you need to dump into it or write some Python to analyze or something. Now it's much more convenient and efficient to diagnose some problems, right?
Exactly. So there's strace, eBPF tools, and GDB. I mean, so my friends now, but this can help.
Yeah, I'm like, since it's a Postgres hacking session, let's maybe like I will try to shift us a little bit to Postgres source code. For example, I have a question. If you trace it with eBPF, probably you can connect not like some wait event, not to query ID only, but to some part of the source code. Is it possible, like, to say, okay, this particular wait event is happening is here specifically?
Yes, it's one of my thoughts to find the code path that contribute to this. Yes.
Somehow aggregate it. Maybe the same wait event happens in multiple places, and you can aggregate them and like zoom into, like, for example, class. By the way, I would rename it to type, wait event type from persistent activity, right? Then event, and then like also even deeper, like few places in source code where it happened, right? Could be interesting, which you don't see it in persistent activity. We don't have this column, but if you deal with eBPF, this would be amazing. Like I reproduce the problem. Not only I understand what we are waiting on, like some lightweight log, but also like I know that only like 90% of this event is in this part of the code and 10% in that part of the code. Wow.
The next thing he's going to do is make you hook it up against the explain plan and then the executor, and
that's a bit like I'm going to propose this. I don't understand why. Again, like I have this idea, like why it was not proposed. Explain analyze buffers should have wait events also. Like one execution should be possible to see where time was spent, even for like one execution. And doing that probably it will connect this micro level analysis to macro level like this analysis, and like, yeah. So you're talking about a big problem, how to jump between like whole picture to specific query and specific execution of that query, right?
Right.
Yeah, that's great. Great thoughts. But I guess, Dmitry, so far what you developed, you are inspired by what Oracle ecosystem has, right?
Yes, but, I mean,
Yeah.
it's inspired, heavily inspired by Oracle, of course. But with the true tracing approach, I think we can go even further than what Oracle does not have, at least yet. I think I have a couple of ideas, like how to find the. I mean, for one of the biggest problem when you investigate the performance clash, to distinct the backends that caused the problem and who suffered from the problem. And I hope that with the tracing, I would be probably able to find a way to do it. I mean, to understand who caused the problem, who started the
Chain,
snowball.
right? Yeah.
Yes.
So root cause
Markov chain,
analysis.
yes.
Can you talk about this a little bit more, like why Markov chain and what? Like you mentioned the book in our private discussions. You mentioned the book you're reading, right?
Yeah, I mean, there are a couple of quite old books about the queuing theory and the Markov chains and so on. So with the as soon as we have a tracing, we know each transition from one wait event to another, and we can find not just number of wait events and duration, but the consequence of them. And from that, I think we can build the chains and can understand what caused the problem and what was the consequences of this problem, and probably find some hottest path in. And what even more, for example, with the classical weight event analysis, you see that, for example, a lot of blue, and it means that you have a heavy IO load. And if you solve the problem with IO, it will solve the problem with your performance. But with the Markov chains, probably you will understand that even if you solve the problem with IO, the actual problem is lightweight logs after that.
This is what we just discussed with Kirk and the question about PG-stat statements. So PG-stat statements has some observer effect, which this is why Kirk is not using it, but it is shown in PG logs, and I started to doubt, like, is it PG-stat statements or you also have heavyweight log contention problem? And when PG-stat statements are slowing, like due to some observer effect, which should be lightweight log, it slows down all the queries. Another problem you also have becomes much more visible, and you think this like. Yeah, and I think in this case, if you are able to to understand those chains, right, it should be possible to understand the root cause and additional problem, right, to distinguish them and then solve them all. So, right. Yeah, I'm super curious. I know you haven't released this project yet. We have a fork here. Either we need to dive deep into discussion about Postgres source code, or we should spend a little bit more time. Yeah, let's do this.
What did you implement?
Because I have a lot of practical discussions, because Dmitry and we are working on these observability tools, like monitoring on top of PG Watch and going up and down. Also a lot of experiments, reproduction of various problems, and I'm curious how we can use this to reproduce various problems, and when it's okay to use, when it's not. So yeah. Anyway, and you haven't released this project. It's called PG Weight Tracer, right? You haven't released it yet.
PGWT, yes. I made the deep review of the quality of the code, and I'm not happy with it. So that's before I release it, I want to be proud of it. So that's why it's still not open.
I can help with this. I can point an army of agents in Polish. It's not a problem. Especially on Wednesday and Thursday when turns out that some of my accounts have some quota to be spent, weekly quota. This is time when you, like, I guess we all need to develop our weekly cycles attached to Cloud Code quotas. Anyway, let's talk about Postgres. You mentioned before this call, you mentioned that you have some thoughts about how it could be better organized in Postgres and what Postgres core could, like, how it would be improved to make this type of analysis more convenient.
Yeah, basically why we cannot just use regular eBPF approach for tracing all wait events. I mean, set and unset. It's because of how it's done now in Postgres. The functions that used to set and unset wait events are inlined, and they are optimized out by compiler when you compile Postgres. And it means you cannot find any way to catch this. I mean, to attach to this function call or any probe does not exist there. It means, I mean, you cannot find it. And any of existing regular approaches does not work. That's why I thought it's impossible. But why is that? Why we cannot just add probes to the set and unset functions? So just two lines
maybe
of
let's
code.
look at the code. Maybe let's look like some. Let's maybe grab some wait event and look at the code.
Some C code would be nice to look at while we talk about this, right? Because the people we're attracting are trying to hack on the C code as well, right? So I get what you're saying, and I can visualize it in my head. And the challenge is they're probably using macros. It's ending up getting, inlined by the compiler, right? So it doesn't have to do a function call and a return and a stack reprocess. And that's an optimization we need and want. The downside to that optimization is that we're losing a point that we could actually track with a tool that says, hey, we entered or exited this actual set or unset function. And I think what you're proposing is, hey, why don't we add something to the set unset so that when it does get inlined, everywhere it inlined it, we now have our probe.
Yeah, exactly.
Right? Okay. But I think it would behoove us if we could pull up an example of one of those wait events in the C code, and forgive me, I don't have one of my screens up, in order to actually, so people can see that on screen. And, because I think it'll make more sense to those of us who don't write code in our head. Right?
Yeah,
and they're learning
or on the whiteboard, as I did in my university all the time. We didn't have computers. Studied computer science on the whiteboard, but it was actually a great experience. As I now realize. Anyway, who will be sharing?
Oh, I didn't. I haven't been working on pulling it up. Are you trying to pull it up, Dmitry, where you can pull up a piece of the C code?
I can find the names of the functions, but I mean, I don't have the source code right on the machine.
Yeah, I have a lot, and there is function pg start report wait start, right? I will show it in a moment. Maybe let me do this work. I have some stuff here and there. I'm sitting in with Cloud Code in your repository because you provided me access. Thank you so much. And here is what I'm asking. I explained the same complaint as you did. Like, why cannot we use regular eBPF analysis for all wait events? So are you saying like some of wait events are fine, or
I mean,
all of them are not fine?
Some of them are fine. So, for example, for lightweight logs already existed
this is what I see
solutions
here.
for lightweight logs. So, I mean, there are projects already available.
Because of this, right?
Yes.
So the idea is all wait events should pass through some function when it starts and when it ends, instead of.
Yeah. So it's actually already happens. So I'm just.
So what's the problem then? Like there are bad examples, or?
I mean, for example, some IO functions IO calls goes through other code path, but anyway, so the functions that called every time, that's called set and unset. So wait event set and unset. They are inlined. I mean, so every time they're called, the compiler actually copies the function code, and they are not call any.
You cannot track this.
Yes, I mean, even with the debug symbols and so on. So they're just, I mean, do not exist after compilation.
So yeah, okay. Like this, for example, right? LW loc acquire. But like this, right?
It's like that, but it's not the lightweight version, right? So where are the calls for the actual weights?
Base lock step enabled. Lock. Okay, so this is a function where what would lock acquire. Actually, this no, or you need to go inside. I cannot go inside here.
Search for one of your wait events, one of the normal wait events.
For example, like what?
Wait for IO. Wait for.
Also, there are runtime computed wait events. Also interesting, right?
So, so that's the link that I was. So let me share the screen. I think. If you want.
Okay. I guess I get the idea. We need some like function which will be unified for all wait events, right? And
there is. Yeah, please.
Yeah, I'm saying like there should be one function to start and one function to end. It should be unified for all wait events, and then it will be possible to develop tooling using a BPF to intercept such calls, right?
Well,
yeah,
I think we have. Doesn't that exist though? I think the piece we're missing is the inlining. When the compiler optimizes it and inlines it, it no longer is making a function call. And because of it, you don't have one spot in the code that you can monitor, hey, when this executes, trip something. What happens instead is you get 10,000 of those or 100 of them spread throughout the code. And the challenge is what we need to do is modify the actual code. And that's what I was hoping we could find.
I see. Okay.
Is the set unset for the wait. There you go. Yeah. That's what we're looking for.
This is fresh. Jeremy Schneider again from January. Fresh.
Exactly. So, I mean, there are functions, they do exist.
Search for that function. Nick, if you can search for that function, PG stat report wait start.
Yeah, this is what the first thing I found. Yeah, I showed it. Okay. The first thing I showed it was this.
I kept saying lightweight lock on that stuff.
No. The first thing I showed it was this function, PG stat report wait start. But I understand when it's compiler optimizes.
It's in line.
Yeah.
Right. So we need something. We need to emit something in here, make it part of that function. So when it inlines it, we have the probe, or did you call it a probe, Dmitry? That you wanted to put there? What did you want to put inside the code?
Yeah, some static trace point like Jeremy Schneider called proposed, or probe anything that would not disappear after compilation that we can attach to. So it can be USDT, for example, that eBPF can attach to.
Interesting. That should be a small ask to get into the function, right?
Yeah. But again, like all wait events go through this function or
Yes.
no?
Yes.
Okay, good.
Yeah, so what's happening is you pass in the parameter of which wait event you're waiting for, I would assume, and then, but you have the core code. And what we want to do is we want to inject something in there, okay, so that we can actually see it whenever it's tripped. And then you're going to do it twice. Are you going to do it at the beginning and end of that code, or differently for the set and the end, the start and the end? How do you track the difference between the start and the end with the subsequent wait events? For timing how
Okay,
long the wait event took, you need both
Mm-hmm.
the start and the end.
Yes, with the, I mean, the tool that I showed, so we registered both. I mean, then when it called start and end. So I mean, we track time.
Anything else in this thread in
No,
PGSQL
just
hackers? Just a question. Nobody is. Yeah, there is a
and
response here.
just yeah, and that's it.
Can you? That's it. Okay. So,
I will send the
let's
link. Yeah.
hold on. Yeah, that's great. So, okay, I'm already implementing it for lightweight logs first as a proof of concept. Let's see what will happen. We need it for both start and beginner, start and end.
Start and end. Yep.
And we'll
Look at
and
Andre.
also,
He's already telling his team of AI agents to start attacking this problem.
no, for now just Cloud Code. Well, yeah. Well, then we will start iterating. So expectations for I'm curious why it's not there.
I believe it's performance. I think we
Let's
will pay
okay.
some.
Okay, so you expect big observer effect from these things, right? We need to
I
benchmark.
personally, I do not, but I mean,
Proving will be hard, maybe.
That would be the pushback, right?
Yeah. So
That'd
we
be the
need to
pushback.
benchmark probably on different platforms, different
Or
processors.
does this become some kind of a guck? Right? Do we create a guck for this to enable it?
There will be different kind of pushback for this. Right. Yeah,
Well,
interesting.
because that's what you have to, right? Because if that's slow, then the
Maybe
if
not.
condition, right?
I expect instead of GAC, it would be easier to have compiler configuration parameter, like enable cassette, like these things, like enable wait event tracing.
Yeah, but I would say
it's pity.
That would make this tool less useful.
Last time
I would be able to use it.
Yeah. So it's better to try to consider this as enabled by default, right?
It would be fantastic. I mean, for any load systems.
I'm going to propose some small thing like as POC in our Telegram channel first. Let's iterate on this, right? Like think. Nobody tried yet. Like, is my Cloud Code the first who is trying this? Yeah. Okay. Let's think about methodology to benchmark like what kind of workloads. Like we need to emulate a lot of
switches.
Switches. This is the trickiest part. The first thing I think, like maybe, if first like iteration, if we have like just four CPUs, like in your example, small machine, but we have 32 or 64 active sessions, there will be a lot of context switches. But will it mean we will have a lot of wait event switches? Yes or no? This is not obvious to me.
So based on test that I did, it depends more on the type of load, type of work the backend does. The maximum switches that I got was when it read data from memory, from OS cache. So it's nanosecond speed was, just from one copy from memory to memory. And in this case, it was up to some 100K of switches per second, I think, something like that. It was maximum that I squeezed. About the context switches, probably it's not, but
we need super frequent, like inside millisecond. I would like to have a lot of wait event transitions.
How about running it, turning this on if we develop the flag, and then running your select one TPS PG benchmark at various levels.
Oh,
and
yeah,
see
that's a
what type
great
of
idea,
impact.
actually. Yeah. So 4 million TPS means that it's 4,000. No, how? Like 4 million per second means 4,000 per millisecond,
Right.
right?
Yeah.
Mhm.
But it's using many many sessions.
Right. Of course, but that's going to be important to test as part of the actual impact of
I
this.
mean,
So
we
this
need.
will answer the question: does the multiple backends will they
No, no,
collide
no, no,
too?
no, 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 no. I don't think we need to think about many backends. We need the proof that observer effect is low should consider. We need to zoom into one session and see a lot of transitions within millisecond and say with that many transitions, like without this and with this, difference is very low. Because if we involve other sessions, I don't see we don't in that particular benchmark there is no like anything between sessions. They are all independent. They of course compete for some resources, right? Like
For
CPU,
PV
but
stat statements, for right, which you probably have turned off for that
how
example.
many we had maybe 196 backends matching
192.
192 matching Xeon Scalable Generation 5 CPU on GCP or AWS, and it means that we need just to divide by 200. So if it was 4,000 per millisecond divided by 200, it was 20 per millisecond, which was already not bad, right? Select one statements or select without one, just select semicolon statement. 20 per millisecond, is it enough to say it's super fast, a lot of switches, and it's enough for us, this workload is enough for us to study the difference with this, without this, or it's
Here's
too
the answer.
low
The
frequency?
trace, ultimately, the trace file that we produce after it will give us the answer. So if we get an
The,
actual file from this,
yeah,
it'll tell us how many times we actually hit our probes.
Mhm.
And that is going to be the actual measure. Because if we
we
hit the
know how
probe
many times.
once per well, how do we know how much?
20 per millisecond means 40 times. So it will start and no, like 40 times we
No,
will
no,
hit.
no. But the probes are based on the wait events that actually trick off. And there could be two or three. There could
Ah,
be a memory wait
yeah,
event,
yeah,
an
yeah,
IO
yeah.
wait
I
event, a
agree with you.
CPU wait event, right? And then you get
Yes,
those wait events. And this is why multiples matter, because you might
yes,
be
yes,
waiting to allocate against somebody else.
yes.
And so, but that's for me, it's the first thing that came to mind that you can throw together and you have something to compare it against.
Yeah.
And right, so you start comparing that, that'll give you a measure of the impact. And it's probably a worst case impact because you're doing select nothing, like in some regards, but you're hitting the pure mechanisms of a select statement being parsed, executed, returned, session, boom. And that would be the, pretty extreme set of overhead to me, to watch that.
All right. Yeah. Well, let's see. And this is first iteration of benchmarks we came up with. Yeah, we have this something already. It should be straightforward, I guess. Oop. Yeah. So yeah, it's very small. You see this? That's it. It says that's it. Okay. For like just to start. Oh, and it covers all wait events, I guess. Like I doubt it will work, but anyway, trivial patch, but the like.
But that's not, Dmitry, correct me if I'm wrong, that's in line with what you were thinking, is how small the patch is. It's
Yes,
a small
exactly.
change. Yeah.
Yeah.
Yes.
Mhm.
This is not
Okay.
unrealistic. I didn't grok the code you threw in to see how it was generating either the probe or some message.
I mean, how my tool works, you mean?
I'm sorry, say that again, Dmitry.
Yeah, I didn't get your question. Sorry.
Oh yeah, I didn't understand the line of code that was the tooling line that we added. What did we add? What line of code did we add in this start and end for us to be able to track the timing?
I think it was USDT probe, right, Nick? So
Yeah,
Use
let's look at
TG
this.
probe. Yeah, let me look.
Just this and that. Passing await event info. That's it. Looks trivial.
And where's the trace function? But that's the existing, isn't it?
This is existing, yeah.
Yeah, so that's so what I'm looking.
If it's existing, what, like where is it used, right?
Oh, yeah. Let's see the definition of that. Wait event info.
It does. I cannot click. I'm bad GitHub user. You know, it's not existing yet, so it's not work. I guess it's not implemented yet.
Hold on. USDT probes.
Yeah.
U probes. Okay. And that's what you were saying was the USDT probes, Dmitry?
yes.
Jeremy Schneider said this, right? I just made a screenshot. Yeah. I threw it to Cloud Code.
Nice. Yeah, that's what I was just. Okay, good. So there's basically going to be this is basically a probe. A probe is set up. Now, I think of the probe as the monitoring, and the code is actually executing like a strobe. It's blinking an LED that someone's monitoring is how I think of this, right? And then you're just sitting on the outside capturing the LED flashes. Okay, yes. Got it. And that's interesting. So now when you're talking the Markov chains, and forgive me, I'm really slow at catching up to some of this, but when you're talking the Markov chains, now I think I see it. So you've got a series of events that tell you, hey, this happened, then this happened, then this happened, then this happened, based on the start and stop times of these events happening. I'm wondering, so you might technically need to combine these from multiple backends to actually figure out what you're trying to figure out. Yes. Right. So now what you're getting is you're getting a topological map in which you should see an initiator that creates this wave across the topology.
Indeed. Yeah.
Okay. That's interesting. I like that. So
and here it explained why uprobes cannot work, showing some examples. That's good. Good stuff. We just need to iterate, review, involve Andrei, I guess, before we finalize this. Yeah. So yeah, and it found discussion raised by Jeremy just by screenshot, like boom. So
nice.
Yeah.
All right. Wow. Well, Dmitry, keep me posted. Keep us all posted on this. This is great stuff.
It's cool. Okay, so I already spawned a team of AI engines. My Cloud Code spawned it. It has permissions to provision the virtual machine. They will do some benchmarks. Pull request posted to chat. I will post it to Telegram as well. We have Telegram group. Also, I will post all the links to this video.
Are you on that Telegram channel, Dmitry?
Yes, he is.
The one for the vibe hacking?
Yeah, hacking Postgres, yeah. So let's see what Andrei will say as well. And then I'm like based on greater minds, I'm ready to present this patch like I did it, but of course, or anyone else, anyone can pick this up. I'm not the author at all here. So
nice,
good stuff. Yeah, let's. My expectation that we will be able to prove that this should be done without any flags.
That would be great.
Yeah.
Yeah, it would be fantastic.
Yeah. In this case, your tool should be improved, right, Dmitry? right? So it will
I
be
mean, it would be simplified with this. I mean, I would just rewrite this, some small piece, I mean, how it gets the data. I mean, the rest would be the same.
cool. And final question about your tool. When do you plan to present it and make public?
A beta version at least.
Yeah, alpha.
I mean, I hope really soon. I mean, I hope that it will be done even probably this week. But as
Quality,
I mean, why we
right?
delayed?
Question.
Yeah,
Okay.
we delayed the
Great.
start because I mean it stopped working.
Right. So quality question. I'm going to help you in this case. Good stuff.
Super.
Okay, thank you so much for coming and showing this. Cool.
Thanks a lot.
Pleasure
I
meeting
mean,
you, Dmitry.
Bye.
I hope